to overcome the fusion. And so molecules can collide or particles can collide at high speed. Yeah, it is like condition for nuclear fusion. It should be high temperature, high density. High temperature, so we can overcome the electrostatic repulsion because two nucleus are repelling each other.
And high density.
No, this formula, you don't have to use this formula. This is not part of the syllabus at all. Like mv square. No. If a formula is not there in the course, you're not supposed to use. Describe what happened to the acceleration. This is a doubt from 0 to 0.04. So what happened to acceleration in the beginning? The acceleration is constant. At the beginning, the acceleration is constant. Then what happened to acceleration? It decreases. And then there is no acceleration or zero acceleration. So describe what happened to acceleration and explain why this happened. So why this happened? This is a ball is there which is falling. So you drop an object from the certain height. Initially, the only force which is acting on the object is a weight. When the weight is acting, the only force weight is acting, so the object will have an acceleration due to gravity. So this point, it has an acceleration due to gravity. Okay. Then what happened? Because the object will accelerate, so speed of an object will increase. If the speed increases, what happened to the air resistance? The air resistance will also increase. If the air resistance increases, what happened to the resultant force? The resultant force will decrease. Because the resultant force is weight minus the air resistance. This is summation, sigma. So, yeah, this is a Greek sigma. Weight minus the air resistance, because the weight is constant and air resistance is increasing, so the resultant force decrease. If the resultant force decrease, the acceleration will also decrease, but the speed continue to increase. And eventually what will happen? The weight balances with the air resistance. Once the weight balances with the air resistance, the speed is constant. If the speed is constant, there is no resultant force or no acceleration. We call that as a terminal velocity. So you have to write a structure answer for this. Falling object will have a constant acceleration initially. Because it is accelerating, the speed increases. Increase in speed cause the air resistance to increase, which reduce the resultant force or acceleration. And eventually, there is no resultant force when weight is balances with the air resistance. So, a structure answer, you have to learn the answer for this. What? The next is draw a tangent on a figure 1.1. Determine the value of acceleration of the ball. So how to join 1 point? So first we have to draw. We want an acceleration at 0.01. So what I have to do first, I have to mark a point where time is 0.01. So this is a point where we have 0.01. I'll just zoom in. 0.01. Yeah, 0.01 dimension here. No. So you need the first topic 1.2. So this is a point where we want an acceleration. So you have to draw a tangent. Tangent is a straight line which only touch a single point on the curve. So length of a tangent, it's up to you, but at least draw 5 centimeter or more. And it has to be over, yeah? Yeah, when it is, look, if a curve is down, like if a slope is decreasing, tangent should be above. If a slope is increasing, tangent should be below. Like if the graph was like this, then where I should draw a tangent, I should draw a tangent below. So if the slope is decreasing, tangent should be above. If a slope is increasing, tangent should be below the line. Because using a tangent, it gives a the change at a very small interval. We need an acceleration at a certain point. So we draw a tangent, length of a tangent, it's up to you.
Can take 2 points, right? The tangent has to be near the line, or can you just touch the point?
Touch the point only, touch the point. That point which we need.
Then how will we know
Sorry.
if it's still not connecting?
What? It is just touching that point.
It
So
is-
how can we do it?
Then
No,
just
the-
Only
touch the
touching that
edge.
point.
Then just touch the edge.
Yeah.
But you throw hole.
Not the whole, just the point. This,
Example.
no, I'm using this screen. So this is a single point.
It's just
See
touching the line
Yes.
where?
on the right.
No. Which one is touching? See here. Only single point it touch. It does not touch here. It does not touch here. So then we have to use a point. Like example, the first point on x-axis, that will be x1. So this will be x1. The first point on y-axis will be y1. So 10 boxes equals to 0.02. So each is 0.002. So this will be 0.022. Then the second point on x-axis, What? finding a gradient of the tangent to get the acceleration. No, I thought he's asking, अब क्या करेंगे?
Says 0.01 that
So 0.21, 0.021, 0.222324. So 0.024. That is x2.
why so called?
What?
It does.
Then this is y2. So this is 1, 2, 3, 4, 5, 0.05, 0.052, 5456. So 0.056. No, I'll write the formula y2 minus y1 over x2 minus x1.
Say can we do like this? Find this over here and then.
Yes. You can do, like you can take any, why I took the first point as on x-axis as 0. So it will just increase the distance between the 2 points. I can take any 2 points after drawing a tangent. Even I can take any 2 points before this. I can take any 2 points after this, or I can take 1 point before and 1 point after, or I can take the starting point and the final point. Anywhere, it's up to you. Any 2 points on a tangent you can take after drawing, and then using a formula, x1 is 0.
0.01 से क्या मतलब?
Seconds.
0 means we need this acceleration at that specific point.
So like हम लोग से
So we need, look, whenever we need an acceleration at a specific point, an acceleration is not constant. That's why we have to draw tangent. If this was a graph, let's say this was a graph and it was a straight line. Yes, for these questions, they always give the range.
Different broker, go different broker.
Yeah, usually plus minus 10% is there of the true value. Let's say this was a graph
then we take
and they ask find the acceleration at 0.01. In that case, I don't have to draw because it's a straight line. So I know the acceleration at all the points is same. So I can just work out the gradient of this whole line and I'll get the answer. Like I don't have to draw tangent, or I don't have to take this point at all. I will just take 2 points anywhere on this line. And I know because it's a straight line. So if I find the gradient of this straight line, the acceleration is same throughout. Like it is same as 0.01, 0.02, 0.03, 0.04. So it won't make difference to the answer. Okay.
The initial acceleration is constant. Then it's increasing.
Let's say initial acceleration is constant and then increasing. Then you you mean acceleration is increasing. So let's say this is your question. First it is constant and then it is increasing. Okay. And then they ask us find the acceleration. But if the acceleration is changing, they will ask us, like if they ask find the acceleration from 0 point, like any point between this one, I will just use a gradient. But if they ask us find the acceleration for 0.3, 0.03. So what I have to do, then I have to mark a point where time is 0.03 and then I have to draw a tangent below this.
Can't ask us the overall.
No, it cannot be, because why it cannot be? Because the acceleration is changing. So if it is changing, then they will ask at a specific point. If it is not changing and they ask a specific point, it means you need an overall because it's not changing. Average acceleration. If they ask an average acceleration, then you have to find the acceleration for the first section. Then you have to find the acceleration for the second by drawing a tangent and then take an average. How, like, add the two mean, divide by 2. But this is like not up to not even A level. They don't ask such a question. They no, for A level it's low, but for IGCSE it's high. So it's not it's a moderate question.
क्या मतलब से low है?
Means like they're learning things which are higher than this acceleration. I'm talking about A levels. Figure 3.1 shows a small block of ice float in a beaker of a warm water. Because
Density उसकी कम है.
Mashallah. Why ice float? Because ice, even it's a solid, but it has low density. The particles are arranged, so they have the ice is having low density, so ice always float on the surface of a water. No, but it's not like it. Look, the thing is not about the floating of a substance. Depends on the state. It depends on the density. So even if you have a solid which is having a low density than liquid, it will float. What?
Mass over volume then.
Density is mass over volume. Density, the density affects the floating and a sinking rather than the state.
नहीं solid में वो खूब float करेगी.
Because it has, in this case, because in a water, you will learn about water that water molecule is having a hydrogen bond, and when these water molecules come closer to each other, they need a large space. So when it need a large space, the volume of a water increases. Like if you take a container, fill it, a bottle is there, you fill completely with water and refrigerate overnight. You will find that the bottle side increases.
Volume or
English.
If both mass and volume are same, then what will happen?
Then if you add the thing which you add at the top will remain at the top. The thing you add at the bottom remain at the bottom. Like if you flip, if you have ice, let's say ice was having the same density as water, and you first put the ice and then you put water, and they have same density, no change. But because if the ice is having low density, so it will always float. How does ice is having a lower density even though it is, because in a ice, the water molecules arrange in a 3D structure. In a liquid state, what will happen? The molecules, 3D, like 3-dimensional. In a liquid 2D, like this is, the molecules can overlap. This is what happened in a liquid state. But when ice is like changing a state, they have a regular structure or a geometry. So because of this regular structure and a geometry, the density of ice is lower, because when they want to arrange themselves in a regular geometry, they take more space. When the same number of particles take more space, that's why the density decreases. That is because of the particles are coming closer to each other and refracting the light. That's why it appeared. Yeah, ice always float. So state one way in which the motion of the particle is ice differ from the water. So in ice it's a solid. So solid, the particles are you have the motion of particles vibrate about fixed position. In a liquid, the particles can move past each other.
Inside the water.
Yeah.
No.
Because we want like how they're different. No, you will lose the mark because every state the particle move unless absolute temperature. Absolute temperature 0 Kelvin. That is also a type of vibration. Vibration because it is very low.
Minus 273 absolute.
Minus 273 degree centigrade or Celsius or 0 Kelvin. Energy is transferred from a water to the block of ice. State the name of a thermal process from which the water, like how energy transfer. Whenever two different materials are there, whenever two different states are there, how the energy transfer between them is by conduction. Like conduction Conduction is whenever two different states are there, two different types of material are there, two different states are there, it's always conduction.
Somebody got out of it. Second. But not.
Initially, so this is conduction. Initially, there is 0.34 kilogram of water in a beaker. The specific heat capacity is 4,200. Calculate the energy from this water as the temperature decreases from 28 to 10. So, E is equals to Cm delta T, the specific heat into mass into temperature change. So, specific heat is 4,200. The mass of the water in the beaker is 0.34. And the temperature change for a water, 28 minus 10. It's always a greater minus smaller. So, that will give us how much energy will be there in joules.
It goes from 10 to 1. From 10 degrees to 100 degrees.
So then 100 minus 10, always greater minus smaller. Then the temperature of a water near the ice decreases first. Describe how the convection causes the temperature of all the water in the beaker to decrease. So we have to explain the convection current here. So what will happen? See,
Where does
where
the temperature decrease?
first they mentioned the temperature near the ice decreases. So what will happen when the temperature decreases? What happened to the density here? Increase, because when the temperature decreases, density is mass over volume. When the temperature at this part is decreasing, so the particles come closer to each other, so the volume decreases, so the density increases.
So the
When particles are closer, the density is high. So the water molecules which are closer to the ice, it is having high density because they are closer, so high density. So high density molecule, what will happen? They will sink. So as a result, the water molecules which are in the surrounding, they have low density, or the cold water molecules, means the hot water molecules, they will rise up. So they will rise because of a low density. So how you explain the convection? The water molecules near the ice are cold, so they have high density. Because of the high density, group of molecule will sink. As a result, the water molecules water molecules with a high temperature have low density, so they will rise, which set up a convection current. That is why whenever you want to set up a convection current, if you should cool from the top or you should heat from the bottom. These are the only ways you can set up a convection current. If I cool from the bottom, it will not be effective. If I heat from the top, it will not be effective.
I say the cold particles displace the.
Yes, cold particle displaces the hot particle, or hot particle displaces cold particle. That's fine.
The second part, they asked us to find the rate at which the energy is not sure.
If in the second part,
That
if they ask us the rate, then energy divided by time. You need a power. What if you heat from the side? Now, if you heat from the side or cool from the side, that also will not set up a convection current. To set up a convection current, you should, the rule, cool from the top, heat from the bottom. If you heat like this side, sideways also, what will happen? The hot energetic molecules will rise and they will escape. So it will not be effective way of heating. Like effective way of setting up a convection current. Effective way of setting up a convection current, heat from the bottom or cool from the top.
21 or 21.
Okay, next. A gas of a mass 0.23 grams is trapped in a cylinder. The gas is at atmospheric pressure 1 exponent 5. The volume of the gas trapped is 1.9 exponent 4. The electrical heater is used to increase the temperature of the trapped gas by 550 degrees centigrade. The specific heat capacity of the gas is 0.72. Calculate the energy required to increase the temperature by. So look what happened in this setup. We have a heater. The heater provides heat energy, and we have a catch here. Catch means like a stopper, like stopping it. So we have a catch here and we supply the heat energy. So the pressure, what happened to the pressure of the gas? The pressure of the gas increases. So when the pressure of the gas increases, we still have a catch. The next part of this question, we remove the catch. So when we remove the catch, what will happen? The piston will move outward. The pressure will decrease, and eventually what will happen? The outside and the inside pressure are same. the piston will stop. So here,
By the outside and inside pressure.
no, it is not same initially. Like you have a cylinder, because when the gas is expanding, when the volume is increasing, the pressure will decrease. So what we have, we supply the heat energy, so we have a hot gas inside. But we have a catch or a stopper here. So outside pressure is how much? It is 1 into 10 to the power 5 Pascal atmosphere.
Inside pressure.
But inside pressure is much higher. Inside pressure is much higher, let's say 3 exponent 5 Pascal, but it will not move because we put a stopper there, a catch. Then what we did, when we remove the catch, the gas will expand. When the gas expands, what happened to the pressure? Decrease. Because as the gas expands, the pressure decrease. So eventually the inside and outside pressures are same. So once the inside and outside pressure are same, the gas will stop expanding.
Outside body.
No, not outside volume. Outside pressure from the atmosphere is same as the inside pressure from the trapped gas. Okay.
This is also.
This is Boyle's law. Pressure and volume are inversely proportional.
Yeah, man.
Nami.
Yeah, only the equation you have to learn. So the question is specific heat capacity of the gas is 0.72.
So what about the initial?
Volume is directly proportional to temperature. Like if you increase the temperature, the volume will increase. So specific heat is 0.72 joules per gram degree centigrade. So the mass should be in gram. If this was in joule per kilogram, then the mass should be in kilogram. Calculate the energy required to increase. So whenever you see the specific heat, so E is equals to Cm delta T, where C is a specific heat 0.72, M is a mass, that is 0.23 grams of the gas, and the temperature change, because we just want to increase the temperature by 550. So the temperature change, we are not saying final temperature is 550, we are saying the temperature has changed by 550. So delta T is already given to you. There's no initial temperature, no final, but the change in the temperature is given 550. So when you multiply them, you'll get the answer in joules. Then calculate how long it will take the heater to supply this energy. So we know the power, we know the energy, so we need time. So power is energy divided by time. So time is energy divided by power. Energy, the answer here, and the power is 2.4. So when you divide, you will get the answer for time, how long it will take. But and they might ask, like in practical, it might take, let's say this answer, example, let's say this answer was 400 seconds. But they will say in practical, it take longer time to reach this. So because energy, when we are supplying, not all of energy is supplied. Some of the energy is absorbed by the container, like the vessel. Some of the energy lost to the surrounding. Yeah, lost to, but wires are losing energy. That is,
By the wire.
yeah, the electrical circuit might. So in practice, it takes longer time. They ask, so give one reason is that, like heat loss to the surrounding, or a container, like the vessel, the gas cylinder takes some of the energy from the heater.
The current gives me out heat. Current gives out heat.
Current is giving out heat. That is what heat we are using.
Is that?
No, that is not a waste. If you're saying, no,
We are saying that.
you're saying this, yeah, this is heat loss to the surrounding from outside. But inside, if it is losing heat, that is what we want. It's better to mention, yeah, like heat loss
To the surrounding.
to the surrounding by the cylinder, heat loss or heat absorbed by the cylinder. Because we assume all heat energy absorbed by the gas. Maybe some of the energy is absorbed by the piston, or
Possible.
what is practically impossible?
Yes, the air getting all the.
Yeah, practically impossible. Because it's impossible that something absorb all of the heat energy.
Mention that by conduction by radiation.
You can mention heat transfer from heater to this by radiation. It absorbed radiation. And then heat transfer within the material by conduction.
And then again.
Then again radiation, yeah. But how many marks? I think it's 1 mark. So you just have to mention. Any other doubt or a question?
Why?